Hello friends, today we will discuss the topic nuclear pollution. Radioactive contamination, also called radiological pollution, is the deposition of or presence of radioactive substance on surfaces or within solids, liquids or gases, including the human body, where their presence is intended or undesirable as per the IAEA definition. Any undesirable effect caused to the environment due to radioactive substances or radiations is called nuclear pollution. Pollution from radiation is a serious environmental concern arising from pollutants released into the environment through human activities. Nuclear pollution occurs when radioactive element comes into the contact with other elements in environment and emits short wave electromagnetic rays, which are serious threat to living organisms. Some elements in this world are naturally radioactive, while some others are made to be. The radioactive substances present in nature undergo natural radioactive decay, in which unstable isotopes with excess protons and neutrons spontaneously give out fast moving particles, high energy radiations, or both at a fixed rate until a new stable isotope is formed. The time that it takes for halfway of decaying process is called half-life, and this differs for each radioactive element. It possibly takes up to 4.5 billion years for uranium 238 and as short as 8 days for iodine 131. Dear students, unstable radioactive nuclei are called radionuclides. They occur naturally or can be produced by various physical means. The naturally occurring radionuclides are isotopes of heavy elements from lead 82 protons in the nucleus to uranium, that is 92 protons in the nucleus. The high energy radiation emitted from the radioisotopes remove electrons from atoms and attach them to other atoms, consequently producing positive and negative ion pairs. Such high energy radiations are known as ionizing radiations. The type of radiation emitted from one radioisotope differs from another. Radionuclides release energy either in the form of gamma rays, alpha particles, and beta particles. These ionization radiations have variable penetration power and ionization. Dear students, alpha particles can be blocked by a piece of paper and human skin. These particles are fast moving positively charged particles. Alpha radiation is highly ionizing, but lacks penetration power. Similarly, beta particles are high speed negatively charged electrons. Beta radiation is somewhat less ionizing, but somewhat more penetrating as well. These beta particles can penetrate through skin, while can be blocked by some pieces of a glass and metal as well. Gamma rays are a high energy form of a radiation with no mass and no charge. Gamma rays are less ionizing, but have extremely high penetrating powers. Gamma rays can penetrate easily to human skin and damage cells on its way through, reaching far, and can only be blocked by a very thick, strong, massive piece of concrete. Another type of radioactive emissions is neutron rays. Neutrons are large and uncharged particles that are emitted from radionuclides. The neutron particles are highly penetrating because they have no electric charge. They are neither deflected nor slowed by passage near charged particles. They move in a straight path until they collide with nuclei of other atoms. They can include radioactivity in non-radioactive substances. Neutrons are produced in atomic bombs and nuclear reactors. Dear students, major radiation hazards are the result of exposure to gamma rays or neutron rays. All these forms of radiation are called ionizing radiations because they possess enough energy to rip electrons away from atoms, leaving charged atoms called ions, and these ions are the primary cause of damage in tissues. Radioactive substance, radiation in the environment are the concerns to the radiation ecologists. There are two important areas of radiation ecology. First is effects of radiation on organisms in the biosphere and the fate of radioactive substances released into the environment. The ratio of a radionuclide in the organism to that of environment is called concentration factor. Radioactive substances, when released into the environment, are either dispersed or diluted, but they may also become concentrated in living organisms and during food chain transfers called as biomagnification. Now, dear students, we will be talking about the causes of nuclear pollution. Nuclear waste and radiation pollution involve any processes that emanates radiation in the environment from a number of sources. The most common ones include: number first, mining and refining of uranium. After mining, the ore undergoes a milling process, which it is crushed and treated with a solvent to concentrate the uranium and produces yellow cake, which is a material containing 70 to 90% uranium oxide. Naturally occurring uranium contains only 0.7% of the fissionable uranium-235, which is not high enough for most types of reactors. The enrichment process therefore increases the uranium-235 content from 0.7 to 3%. A process known as fuel fabrication then converts the enriched material into a powder, which is then compacted into pellets. The fabrication of the elements produces three kinds of radioactive pollutants, that is solid, liquid and gaseous wastes. These pellets are then sealed into metal fuel rods about 4 meters in the length, that is then loaded into the reactor. These rods are a major source of radioactive waste material produced by a nuclear reactor. At each step in the cycle, there is a danger of exposure to harmful radiation and poses several attendant health and environmental concerns. Dear students, now the second is the operations conducted by the nuclear power stations. The nuclear fuel used in the nuclear reactors contains uranium-235. Nuclear fuel does not burn like fossil fuels, but reaction that drives the release of a nuclear energy in power plants is nuclear fission. When an atomic nucleus is split apart, atoms do not split spontaneously. Inside nuclear reactor, uranium-235 atoms undergo fission reaction. When neutrons strike them and once they split, uranium atoms give off an enormous amount of energy. Fission byproducts, like when a uranium-235 nucleus splits, it produces two smaller nuclei called daughter nuclei or fission fragments. Over 400 different fragments can form during uranium fission. Many of them are highly radioactive. Once uranium-235 nucleus split, they also release neutrons, which strike other nuclei in the fuel rods, creating a chain reaction. The dear students, the heat generated by fission is so intense. Dear students, the heat generated by fission is so intense that if the chain reaction is not carefully controlled and temperature rise is not checked, that it would soon melt the contents of the core and walls of the nuclear reactor, with massive leakage of uranium and its many radioactive products, and thus send tons of molten slag through the floor of contaminated building. This is known as meltdown. A full meltdown would be an environmental hazard, releasing high levels of radioactivity in the air, soil, and both surface as well as groundwater. The radioactive emissions to the air vary with the type of reactor. They include nuclear fission products and neutron generated nuclides. Another operation of nuclear power plant involves reprocessing of the spent fuel, which includes chemical treatment to separate the reusable components of uranium-235, uranium-238 and plutonium-239 from waste fission products. In this process, gaseous waste fission products such as tritium-3, krypton-85 and iodine-131 and large quantities of liquid wastes containing half-life nuclides and some high active solid wastes are also produced. Dear students, 3 Mile Island nuclear power plant leakage in the USA in 1979 and meltdown of the Chernobyl nuclear power plant in the USSR in 1986 are the examples of nuclear power plant accidents causing escape of the radionuclides in the surrounding environment as well as in the atmosphere. Now, dear students, we will be talking about the nuclear explosions and detonations of the nuclear weapons. Of all the activities concerning nuclear weapons, testing has been the most destructive of human health and the environment. Nuclear explosion is responsible for nuclear pollution, which is carried out for performing nuclear tests and for making nuclear weapons. Due to this explosion, about 15 to 20% of the radioactive particles enter into the stratosphere. Nuclear explosions are very rapid, and based on a rough estimate, in an explosion about 50% of the energy goes to the blast, 33% as a heat and rest 17% or so as radioactivity. The nuclear explosion matter is vaporized to hot gas with very high pressure, several billion atmosphere, by heating at a very high temperature about 108 degrees centigrade. An intense shower of many kinds of radiation releases in the atmosphere falls back to the earth in the immediate vicinity of the blast within hours. The radioactive dust that falls to the earth after atomic explosion is called radioactive fallout. Now, the defense weapon production. Production of a nuclear weapons involves the generation of a large quantities of waste material and contamination of surrounding areas. This process generates large quantities of waste that oftentimes ends up in oceans, rivers and soil. Nuclear weapons produce nuclear waste, which is also called transuranic waste. Most of this waste originates from cleanup and contaminant of radioactive products that are dangerous for the thousands of years and presents the biggest challenge to the humanity or to the environment. But there are also risks in dismantlement of nuclear weapons, including hazards to workers and environmental risks associated with non-nuclear aspects such as missile destruction. These procedures release clouds of toxic hydrochloric acid when the missile's solid fuel combines with moisture. Now, the decommissioning of nuclear weapons. The decommissioning of nuclear weapons causes slightly more radioactive pollution than in the production. However, the waste alpha particles is still of low risk and not dangerous unless ingested. Now, the nuclear waste handling and disposal. The issues with the transportation of a nuclear waste is from one place to the another by modes of a transportation like in air, land, water, sea, possibly brings a serious hazards to the environment if they are not maintained carefully. The radioactivity may thus contaminate and propagate through either air, water and soil as well. The main problem with radiation waste is that it cannot be degraded or treated chemically or biologically. The decaying process of radioactive waste takes a very long time in progress, because some radioactive waste have a half life of more than 10,000 years and are dangerous in great amount of time. The low level waste is from power plants and other facilities, including hospitals and laboratories, are hazardous for about 300 years, and high level wastes can be dangerous for tens of thousands of years. Another problem is the medical wastes. Dear students, a number of radioactive isotopes are used in medicines nowadays, either for a treatment or a diagnostics. Radioactive medical waste tends to contain beta particle and gamma ray emitters. In diagnostic nuclear medicine, a number of short-lived gamma emitters such as technetium-99 are used. This can be left over a short period, after which they are able to be disposed of as normal waste, but X-rays are the greatest man-made radiations. X-rays penetrate the human body as gamma rays do. X-ray exposure causes cumulative effects on the human beings. Now, dear students, we will be talking about the effects of these radiations on human health. Studies have shown that the health effects due to radiations are dependent on the level of a dose, kind of a radiation, duration of exposure and types of cells irradiated. What are the biological effects of these ionizing radiations? Dear students, ionizing radiations bring about more dangerous effects than other toxicants. As already we have discussed, most serious disorders are caused by the radiations escaped from the nuclear power plants and nuclear explosions. Their effects may continue in subsequent generations. The principal effect of the exposure of the whole body to penetrating ionizing radiation is the shortening of a life of the exposed organisms. Radiation effects can be somatic or genetic. Then what are the somatic effects? Dear students, these are direct results of action of radiation on the function of body cells, tissues or the organs. It causes damage to the cell membranes, mitochondria and cell nuclei, that resulting in the abnormal cell functions, cell division, growth and death. Radiologists, uranium mine workers and painters of radium dials suffer the most. The somatic effects may be immediate or delayed. High radiation exposures have much toxicity and kill animal quickly. A dose of 400 to 500 roentgen on whole body is fatal in about 50% cases of a man and 600 to 700 in practically every case. The victim declines in vitality and dies from the anemia, infection and hemorrhage. The parts of a body differ in sensitivity. Yes, the most sensitive tissues from acute doses are intestines, lymph nodes, spleen and bone marrow. The radiation destroys the body's immune response. The effects of a low penetrating radiations are less severe than the penetrating ones. In delayed effects, the patient may survive for months or years. Delayed effects of radiation include eye cataracts, leukemia, malignant tumors, cardiovascular disorders, premature aging and reduced lifespan. Diagnostic X-ray exposure of a pregnant woman may increase the risk of a cancer in the child. More evidence of a degree and kind of a damage from radiation come from studies of Nagasaki and Hiroshima survivors. Second, the genetic effects. Both background, natural and man-made radiation bring about the genetic effects, but most genetic effects are brought about by man-made radiations. People in industry, research and medicine using radionuclides are exposed more than others. The greatest damage is in dividing cells, chiefly the gonads. The effects include mutation that change in genetic makeup of cells, where these effects are mainly due to the damage to DNA molecules, lethal effects on egg or embryo. People suffer from blood cancer and bone cancer if exposed to doses around 100 to 1000 roentgens. Instantaneous deaths can occur on exposure in the event if disasters are many. The intensity of a radiation affects the rate of a mutation. Generally, higher animals are more susceptible to genetic damage than lower animals as insects. Genetic effects also occur in plants. Now, the effects on the environment. The environmental impact of nuclear power results from the nuclear fuel cycle, operation and the effects of accidents. The possibility of a overheated fuel releasing massive quantities of fission products to the environment can cause catastrophic risks to the environment. First, the water contamination. According to World Health Organization, nuclear accidents may produce fallout, which can pollute water supplies for years after the incident. The 1986 explosion of a nuclear generator in Chernobyl, Ukraine, created a large radioactive cloud which polluted existing water supplies and produced contaminated rain in nearby countries. Second, increase in water temperature. Nuclear power plants release heat into water like thermal power stations, and it is obvious that the temperature of a water in the area of a nuclear power station is higher than without it, which disturbs the balance of water evaporation. Also, the amount of salt in water increases. Such changes lead to the extinction of some species of animals. Third, contaminated soil and plants. Dear students, nuclear radiations can contaminate soil, which then leads to plants and pose a health threat to individuals. Researchers explored the Marshall Islands, an area widely known for nuclear bomb testing by the US military in 1950s and 60s. They found that the current soil samples and local foods, including coconuts, meat, contained radiations level significant enough to pose a health risk to individuals. Now, the social and psychological effects. The impacts of nuclear accidents were often not directly attributable to radiation exposure, but rather social and psychological effects. The consequences of a low level radiation are often more psychological than radiological, because the damage from very low level radiation cannot be detected. People exposed to it are left in anguished uncertainty about what will happen to them. Many believe that they have been fundamentally contaminated for life and may refuse to have children for fear of birth defects. Hence, it is concluded that despite the advantage of nuclear as a clean energy, the big concern is the waste that has resulted from nuclear reaction, and if this waste accumulates, it poses a potential hazard to human health as well as the environment. With increasing use of nuclear energy in industry, sciences and the technology, radiation biology will continue to grow, but the radiation and releases from the nuclear plants are to be controlled so that the risk to the public is minimal. With this, we conclude today's lecture. Hope you have understood well. Thank you.